Welcome back to TV News Garbage 24/7 edition. I'm your host, Joe Schmo. Tonight, we'll be discussing soil science. I know, right? But apparently, there's a growing concern over a lack of public knowledge in this field. We interviewed some people on the street just to find out.
Soil science is boring.
Soil science, what's that?
You're talking about dirt, right?
This news bothered University of Vermont professor Ben Dirt so much that he sent his students out to explore a research field on the property. With nothing more than some simple tools and the fundamentals, the students actually found some shocking results that might make you reconsider your take on soils.
Rising up, CBAO. Took some time, took some weathering. Dug the pit and now I'm here to analyze just a man and his Munsell color book.
So many times out in the field, can't decipher the layers. Down with the shovel, destroying the pits. Now you're on the path to compaction.
Found a layer made by a plow, throwing off our map units. Excessive phosphorus found in the field. Now we have the potential for pollution.
It's the soil horizon.
Can you feel the texture?
Wetting up a fresh soil sample.
And the depth to each layer
Is key to ID the species.
And confirm with the NRCS.
soil horizons.
The 3-acre housing complex will be on the 88 southeast corner of the plot. Adams and Windsor loamy sands. It is favorable for unpaved local roads due to its soil strength. The houses will not have basements, poor shallow excavations. The soil is somewhat limited for construction of small buildings, but that can be overcome by special planning and maintenance. From field analysis, no redox features were found, just a thick plow layer and a lighter sandy layer underneath.
The 3-acre housing complex will be located at the southeast corner of the plot, consisting of Adams and Windsor loamy sands. The ADA has few limitations for non-farm uses, such as housing developments. There is only a slight hazard of water erosion. Therefore, the ADA is favorable for unpaved local roads and streets that carry traffic year-round but have a graded surface of local soil material. Not included in the construction rating is its close distance from Spear Street, meaning that less construction will be necessary. The road will run parallel to the bottom of the plot. The Adams and Windsor loamy sands are not favorable for shallow excavations or trenches or holes dug to a depth of 5 or 6 feet. Even though NCRS said that the soil properties are favorable for a dwelling with a basement, if the soil is not favorable at all for shallow excavations, we're not going to risk it. The Adams and Windsor loamy sands are somewhat limited for the construction of small commercial buildings that are less than 3 stories high and do not have basements. The soil is defined as somewhat limited, meaning that the soil has moderately favorable features, and limitations can be overcome or minimized by special planning, and maintenance may be necessary. From field analysis, no redox features were found. The horizons consisted of an upper dark organic matter rich plow layer, about 1 foot deep, and a lighter, sandier layer leached of nutrients. These soils were well drained and aerated. One limitation is that the soils are susceptible to soil blowing where unvegetated, so the soil should not be left bare around the housing complex.
All along it was the texture that pointed me in my direction. Told me where the trees could go, and the species I now know. ADA had the productivity, the clear choice is the eastern white pine tree. Funny how the site index told me just what to do, made me realize the ADA soil was the right way to go, and the average height shows.
I was tasked with determining where a 5-acre woodlot could be placed within our area of interest. I began this task by determining which soils within our area of interest would be the most productive for growing trees. I used 2 measurements. The first was the site index, which is the average height a given tree species can attain on a particular soil taxon. The second measurement was a measure of the cubic feet of wood fiber per acre per year that a species of tree could produce on a given soil taxon. This led me to the soils in the northeast corner of the area of interest, those being EWA, BIA, and ADA soils. This also showed me that the eastern white pine would be the most productive tree within these soils of any given tree that we measured. So the eastern white pine was able to reach an average height of 75 to 65 feet within this area of the plot. It was also able to produce anywhere from 143 to 114 cubic feet of wood fiber per acre per year within the northeast corner of the plot. So this northeast corner, which was made up of EWA, BIA, and ADA soils, constituted 13.1 acres of the entire lot. This was far more than was specified by the developer, who asked for 5 acres of woodlot, so my next task was to narrow this area down. I did so by examining the soils within this area to determine which would be best for the eastern white pine's growth. The eastern white pine tends to prefer sandier soils with high acidity and well-drained soils. So I was capable of eliminating the BIA soils within this area on the basis that the depth to their water table was too shallow and would obstruct the rooting zone of the eastern white pine. Turns out the depth of the water table in the BIA soils is about 45 centimeters when the eastern white pine requires at very most 200 centimeters, but at least 100 centimeters. So the BIA was eliminated on this basis. The EWA soils within this area were eliminated on the basis that they were poorly drained, which is not ideal for the growth of the eastern white pine. This led me to the ADA soils within the area, which were somewhat excessively drained, which is okay for the eastern white pine, not perfect, but the best within that area. The depth to their water table is 200 centimeters, which is perfect for the eastern white pine. Also turns out that the ADA soils are the sandiest. They have 87.1% sand to a depth of 200 centimeters, and the ADA soil was the most acidic. It had a pH of 5.4 to a depth of 200 centimeters. So the ADA soils would be the most productive for the growth of the eastern white pine, and had over 5 acres of area there. So any 5 acres within the ADA soils would be suitable for the woodlot of eastern white pines. My one caution to the developer is to make sure to remove the 8-inch plow layer that was found over the ADA soils, because it could lead to drainage problems. Redox features were found within the soil at about 10 centimeters deep, and the plow layer over the soil was a finer texture than the underlying ADA soil, which could have caused the perch water table. In addition, eliminating this plow layer would also eliminate the abundant grass growth that is in this plow layer, which could provide unwanted competition for oxygen between the roots of the eastern white pine and the grass. And this would obviously be something the developer would want to avoid.
Now this is a story all about how poor soil management ruined the field, and I'd like to take a minute, just sit right there, tell you all about my consulting, we'll fix it, don't despair. In South Burlington on Spear Street is a research plot where they were growing some corn, tilling up, plowing, using bovine manure. They were farming up the land, didn't care about the soil. When a developer came, wanted to change some things, started looking at some soil survey maps, but he couldn't read the units, and man, he got scared and said, I'm calling a certified soil surveyor. So I took some auger borings here and there, sent them up to the lab, hoped someone would care. Got the test back and I couldn't believe it. Excessive phosphorus, guys, you might as well quit it. 17 times more, man, this is bad. Increasing going with manure had some adverse effects, but at least your content is 4.7%. That's almost ideal. I looked at the ADA down in the pit. The horizon had a clear plow layer, screw excessively drained, perch water table sand, maybe tile drains, but I thought, nah, forget it, Heinsberg to the Katina. I pulled up to the slow prime farm and let's go, and I yelled, this is the spot, watch erosion. To feature redox features micronutrients in check, we can grow now, thanks to the Soil Surveyor. It was very hard to decide where to put an agricultural field for this plot. Strictly looking at the topography, we wanted to use the eastern side where there's already an existing field, but the ADA soil series had some limitations as there was a plow layer and perch water table. So we moved to the western side of the plot at the Katina, which has 3 different soil types, according to the NRCS. The Heinsberg soil series, which is a fine sandy loam, is considered prime farmland. You have the Vergennes clay, which has the highest farmland rating, but it's considered a farmland of statewide importance. And you also have the Limerick silt loam, which is also considered a farmland of statewide importance. The clay was non-existent in the map units where it was described. Then the Limerick silt loam had also drainage features, as the depth to water table is 0 to 18 inches, and we found redox features at about 8 inches, so that was ruled out. So the Heinsberg soil series, we took a composite sample of all the areas that had that,
for a soil test, which revealed several things. Excessive phosphorus, which was most likely from animal manures. I suspect that the manure from the dairy operation across the street is being used as fertilizer. Animal manures are high in phosphorus, so instead they should use legumes to incorporate phosphorus, much lower levels. The pH was also 6.8, which is almost neutral. That also coincided with very high levels of calcium. So I also suspect that there might have been some liming of the soil to make it more alkaline, because the aluminum was also very low. It was 15 compared to a level of 35, which is good, but because having a pH above 6 keeps the aluminum from becoming soluble. However, this pH is not necessarily ideal. You might want it slightly more acidic for growing crops. The micronutrients levels were good. Iron and sulfur were slightly low, so my recommendation is to add blood meal, which is high in iron and sulfur, as well as nitrogen. This is beneficial because then the developer can plant heavy feeder crops like tomatoes, corn, squash, anything on a vine. These will really suck up a lot of the phosphorus, but that phosphorus is really a huge limiting feature, and it's definitely going to take some years to remove. So if there is any fertilizer added, make sure it does not have phosphorus, and just make sure, just expect some poor years in the beginning, and otherwise everything will be set.
The ecological and wildlife habitat area will be located where the natural sites already exist, along the stream that latitudinally bisects the plot of land. It will act as a riparian buffer, improving water quality by filtering pollutants, especially excessive nutrients leached from the agricultural field, before entering the waterway. The area will also act as a wildlife corridor for species who had their habitat fragmented by the surrounding land uses. The ecological and wildlife habitat area will include alluvial land, BIA, EWA, and limerick silt loam. In alluvial land, finer materials settle out in the calmer flood waters farther from the channel. The soil around the stream has a high clay content and very low sand and silt, acting as a filter for pollutants and nutrients. Alluvial land is flooded at least 1 or 2 times per year, and some areas are eroded by the current. Adjacent to the alluvial land is the BIA. Although this may be used for agriculture, it is generally too wet to support agriculture due to its poor drainage. The water table may be near the surface during the wetter parts of the year. The EWA soil map unit is also poorly drained, and surface runoff is very slow. Near the bottom of the plot is the limerick silt loam. Formed from alluvium, it is fertile soil for agriculture, but must be artificially drained, since it is poorly drained, wet soil. It is very susceptible to flooding. The soil is shaded by an overstory of deciduous trees. These contribute to the high organic matter and nutrient content of the soil, as well as moderate stabilization of the soil by root systems and prevention of erosion. An understory layer of native grasses can be planted to create a more dense underground root system to prevent erosion and allow for greater storage and uptake of pollutants and excessive nutrients. The stream is the low point between the Katina to the east and slighter incline to the west. Therefore, the conservation of a riparian zone is imperative for surface and groundwater health, for the filtration of pollutants and excessive nutrients. The soil map units in this area are composed of mainly finer textures, clays and silts, which plays a major role in this important ecosystem function.
And that concludes our program on soils. Until next time, I'm your host, Joe Schmo, TV News Garbage. Stay biased.
Soil horizons.
Can you feel the texture?
Wetting up a fresh soil sample.
And the depth to each layer
Is key to ID the species.
And confirm with the NRCS.
soil horizons.